All right, so here is the next one. Once again, we are trying to expand this. So the first thing we can do is we can say, okay, hey, this is all to the power of 4, which means that I can bring the 4 in front of the logarithm. So this would say 4 log base 6 of 216 over x cubed y. And then from there, you can go ahead and get rid of the fact that there's a fraction and split this into multiple logarithms. It's going to be 3 total. It's going to be one with the number, one with the x, and one with the y. And each one of the logs will be log base 6, and each one will have a 4 in the front since all of those were being raised to the power of 4. So it'll be 4 log base 6 of 216. And because that number is in the numerator, that is a positive 4. When we get to the denominator, the 4 is going to turn into a minus. So minus 4 log base 6 of x cubed. And then another minus 4 log base 6 of y. From there, you're going to just continue to do some simplifying if you can. One thing that jumps out to me right away is I have x to a power, so I can bring that power down again. And if there's already a number in the front, those two powers just get multiplied. So it'd be minus 12 log base 6 of x. This one doesn't simplify at all, right? There was nothing, no powers or anything fancy going on there, so that one was done. And then here, because everything is numbers, you can actually simplify this to a single value, and you can use your calculator to help you out with that. So this log base 6 of 216, in your calculator, you're going to use the log button, but it doesn't let you say base 6, so you're just going to do a change of base formula. So it'd be log of 216, make sure you close those parentheses, divided by log of the base, which was 6. And so that value is equal to 3. So this is 4 times this value, which we typed in the calculator, was 3. And 4 times 3 is 12. So it's 12 minus 12 log base 6 of x minus 4 log base 6 of y. So we have completely expanded and simplified this out. All right, we have, it looks like just a few more that we can work on doing some expanding with. This next one is a natural log. And so if you remember, a natural log is just a log, but it has a base of e. So it has this special base there, base of e. And then we have a fourth root here. We have xy over ez. And so we're going to start expanding this out. The first thing I'm going to do is I'm going to take care of that fourth root. Everything is under a fourth root. So that is a power that will move to the front. And because it's a root, the power is 1 over 4 for saying the fourth root. So we can rewrite this as the fourth root of the ln of xy over ez. From there, you can go ahead and start expanding these out. Remember, if it's in the numerator, it'll have a plus. If it's in the denominator, it will have a minus. And they will all have a 1/4 in front of them because of that fourth root, them all being underneath the fourth root. So we can say 1/4 ln of x, and that's a positive term because it's in the numerator, plus 1/4 ln of y, also a positive term because it's in the numerator. Now we move to the denominator, so now this is going to change to a minus 1/4 ln of e. And then we'll have another minus because it's in the denominator, 1/4 ln of z. Sorry. And then looking at all of this, there's actually one thing we can do to simplify, and that has to do here with this ln of e. One of the general properties that we talked about of a natural logarithm is ln of e. And so if you need to flip back a page, then you can take a look. And under the natural logs, it's in this section. It says the ln of e is equal to 1. So this would be 1 times a negative 1/4, which would just be negative 1/4. So everything else will stay exactly the same, but this term right here will become just a negative 1/4 because the ln of e was just equal to 1. So I'm not going to rewrite it. It's just this plus this minus 1/4 minus this. All right, here is another one we're going to work on expanding. This doesn't have anything where they're all being raised to the same power. We have powers here, but they're not all the same power, like they were all in the fourth root or they were all being raised to the fourth or the third. And so this one, there's no power rule here at the beginning. We are going to do some power rules later on. So we're just going to go ahead and start separating this. So we have log base 3 of x squared. And that's a positive term because the x squared is in the numerator, minus log base 3 of 81. And that's a minus because the 81 is in the denominator. And then we'll have another minus log base 3 of y to the fourth because, once again, the y to the fourth is in the denominator, and those go with the minuses in front. They're subtracted. All right, and then each of these can actually be simplified. The x squared and the y to the fourth, those are going to be power rules. So the 2 can come in front, and for this one, the 4 will come in front. So this would be 2 log base 3 of x, and this one would be minus 4 log base 3 of y. And then last but not least, this right here is actually just a number, and it can be simplified, and you can use your handy dandy calculator to help you out with that. So it's a change of base formula. So log of 81, make sure you close the parentheses, divided by log of 3. Close those parentheses, and the answer is 4. And so that simplifies to a minus 4. The connection here also, if you don't want to have to use your calculator, 3 to what power is 81? That's what we're really asking here, because remember, logs and exponentials are inverses. So this is saying 3 to what power is 81? Well, 3 to the fourth power is 81. So this log base 3 of 81 is equal to 4. That's where that value is coming from. All right, I think we have a few more, and then we have some my open math type questions that we'll talk about. All right. So here is the next two. So this is log base a half, and then we have 4 times the cube root of x squared divided by y square root of z. Once again, not everything is being raised to the same power. So because not everything's raised to the same power, we're no power rule at the very beginning, like we saw with those first few examples. And so we can go ahead and just start splitting this up. Everything will be log base a half. And then we'll have a 4. It's going to be positive because the 4 is in the numerator. We'll have plus log base 1/2 cube root of x squared, also positive because it's in the numerator, minus log of a half of y, and it's a minus because it's in the denominator. And then last but not least, we have another minus log of a half of the square root of z. Zoom out a little bit for you. All right. Now you should simplify anything that can simplify. So here, because we have log of a half of 4, this is actually just a single number, and it's 1/2 to what power gives you 4. And you might not know that off the top of your head, or maybe you do. If you don't, though, you can always use your handy dandy calculator, right? Log of 4. Oops, sorry. Log of 4, close parentheses, divided by log of a half. And you can say 1/2, or you can say 0.5. It doesn't matter. Your calculator will read it the same. And so that value is -2. So 1/2 to the -2 power is 4. So you can just replace that with a -2. And then here, this cube root of x squared is a power. So technically this is all the power that will come out to the front. Because it's a cube root, it's going to be a fraction, and you'll have 3 on the bottom. In the numerator, you'll have the 2. So this will be plus 2/3 log base a half of x. And so whenever you see roots, it will be fraction exponents, and so you'll have the fractions on the outside. This one, nothing to simplify, so just minus log base a half of y. And then this last one, you have z, the square root of z, And so square root is technically a 1/2 power. So this will be minus 1/2 because it's a square root. So it'll come to the front, minus 1/2 log 1/2 z. All right, that is it for the expansion. That's as best as it's going to get. So right now, I highly suggest you hit pause, try this natural log one by yourself, see what you come up with. And then when you're ready, go ahead and hit play, and I will have the solution ready for you. All right, so here's the solution for this one. They all are natural logs because our original was natural log. This is a cube root, so you're going to have a 1/3 power when it's all said and done. The next one is a minus natural log of 10 because the 10's in the denominator. If you calculate that, there is a natural log button right here underneath the log, so you could just type in ln of 10 and see if it's a nice number. And in this case, it's not a nice number, so we'll just leave it as the ln of 10. Even though it has a decimal version, we're just going to leave it as this, all right? And then we have also in the denominator a square root of yz. So because both the y and the z were in the square root, they both have the 1/2 powers in the front. And then because they're in the denominator, they both have minuses as well. All right, so that one is completely expanded. All right, so here's some My Open Math type questions that you can see in this section. So it says, given the log base a of 4 equals m and log base a of 3 equals n, write exact expressions in terms of m and or n for the following. So we have log base a of 256. So the trick here is to try to figure out a combination of 4 and 3, and you can have them being raised to powers that will give you 256. So you might want to use your calculator like this. So like for example, 4 to the power of 2, that's just 16. But if we remember, isn't it 16 times 16 is 256? And so you can write this as 4 to a power. And I think 4 to the power of 4 is 256. So what you're trying to do is you're trying to find the value that you're taking the log base a of, but you're trying to do it in terms of either 4 or 3, and you can include any powers that you want. So it's kind of like factoring in a sense where you're trying to like figure out the numbers, right, that make this situation happen. It's the same idea. You're trying to figure out the numbers that make this situation happen. So what we're going to do is we're going to say log base a of 4 to the power of 4. And that is the same as log base a of 256. And so what we can do is we can use our properties to bring the 4 into the front and have 4 log base a of 4. And in the stem of the question, it says log base a of 4 is equal to m. So you can replace this piece right here with an m. So this is equivalent to 4m. And so log base a of 256, we would say, is 4m. And so it's kind of weird because they're not telling you exact values there. They're just saying, hey, in terms of m and n, try to figure out what these logs would be equal to. All right, so let's try the next one. So log base a of 12, when I see 12 and I know I need to try to use 3 and 4, I'm thinking that that is 3 times 4. And hopefully that jumps out to you as well, that you can make 12 out of 3 and 4 by just multiplying them. So the property here says if you have two things being multiplied, you can write them as two separate logs, but instead of multiply, they are now being added. So this would turn into log of 3 plus log base a of 4. And they tell you that the log base a of 3, that's n, and that the log base a of 4, that's m. So you can say this is n plus m. Or you could reverse them and say n plus n. That'll be the same thing. N plus m. All right, so 36 is up next. So we have to try to figure out how to find a 36 with this combination of 4 and 3. 3 squared is 9, and 3 cubed is 27. 3 to the 4th power is 81. So it's not just a 3. It's also not just a 4, but 36 is 4 times 9, isn't it? So that's what we're going to go with. 4 times 9. And we don't have any information about 9, do we? But we know 9 is actually 3 squared. So you should replace that with a 3 squared. So here is the calculation that gets you 36, 4 times 3 squared. And so we'll apply the properties here and replace the 4 and the 3 when they're all separated with the m's and the n's. So this would be log base a of 4 plus log base a of 3 squared. And what happens with the square, the power, it will come down into the front. And so it would be 2 log base a of 3. And so then you're just going to replace the log base a of 4 and the log base a of 3 with m and n accordingly. So it would be m plus 2n. So this one here is m plus 2n. All right, if you want to hit pause and try these on your own, you can. If not, we're just going to keep on going. But if you want to give them a shot, go for it. All right, log base a of 0.75. Well, I know 0.75 is the same as 3 over 4, right? 3/4. And so I have my 3 and my 4 now. This would be a subtraction. Log base a of 3 minus log base a of 4. And so 3 is n minus m. So that one just turns into n minus m. All right, up next is 2.25. And so this one might be a little harder to try to figure out what's going on to get 2.25. So if you want, you can change 2.25 to a fraction. That would be the easiest. So 2.25, change it to a fraction, use this F to D, and it's yellow, so you have to hit that button first. So that's 2 1/4, and that's a mixed number, right? But if you want to put it as a improper fraction, 2 would be 8 over 4, and then you have one additional one. So we're looking at 9 over 4. And if you're not sure, you can always just type in 9 over 4. That is, 2.25, so we know that it is 9 over 4. All right. The good news is we know how to make a 9, and we already have a 4, right? 9, that's actually 3 squared. So log base a, 3 squared over 4. And then you can go ahead and expand and apply those properties. So this would be log base a of 3 squared minus log base a of 4. And the power here will drop to the front, so you'll have a 2 in front of that. So that would then change to 2n minus m. 2n minus m. So that would be what that log is equal to. All right, and last one, we have the 6th root of 3. And it might look complicated because there's a 6th root, but the really nice thing is that they give us a 3, don't they? So really what that is it's log base a of 3 to the power of 1/6, right? That's what a 1/6 does. And the 1/6 can come into the front. So we would say 1/6 log base a of 3. And that log base a of 3 was n, right? So this would be 1/6 n, or you could say n over 6. So here we would have n over 6. All right. Kind of a different type of question, working with the properties, but in terms of using numbers and then variable equivalents for them. Okay, so this says expand into a sum or difference of the simplest logarithms possible. So we're going to simplify this, and then we're going to expand it. So I see a quadratic and a quadratic. So whenever you see quadratics and something says simplest or simplify, you're going to want to do some factoring here. So the numerator would factor two numbers that multiply to be negative 15, add up to be negative 2. That's minus 5 and positive 3. The denominator, still a quadratic, but it only has 2 terms. So looking at that, I can tell that they have something in common, and what they have in common is an x. Left over would be x minus 5. And you're doing the log base 5 of this whole thing. And so we can simplify, since we have x minus 5 in the numerator and x minus 5 in the denominator, those two things will simplify to make a 1. And so we can say this is log base 5 of x plus 3 over x. So immediately, just by factoring and simplifying the fact that we had a division here, we were already able to make this log simpler. And then now we're going to go ahead and expand it. So we're going to do log base 5 of the numerator, which is x plus 3, and then minus log base 5 of x, and it's a minus because the x is living in the denominator. One more thing I want to point out, the numerator, it has two parts, but they're being added. They're not being multiplied. So this will not split any further. There is no property for two things being added inside of the logarithm. If they're multiplied in here, this said 3x, then you could go ahead and split it into 2 if you wanted. But since this is a plus, it does not split. So be extra careful there in terms of what you recognize as able to apply the properties. The plus versus the multiplication is a very different situation. And so here, no properties in the numerator, but if that was multiply instead of add, then you could do more properties with the numerator. All right, and last one for this section, I believe, right? Yeah, last one. Okay, so we have simplify the following expression as much as possible. Your answer should not contain any logarithms. All right, this one's kind of different because we have e to a power. I know it's super small. Let me zoom in. So we have e to a power, and that power is 9 ln of x plus 2 ln of y. And the first thing that we're going to do is we're actually going to apply a rule of exponents that say if you have two things being added in the exponent, it came from two e's being multiplied. And one of the e's had 9 ln of x. The other one had 2 ln of y. And that's actually a property from Algebra 1, that if you have two things being multiplied, they have the same base, and in this case, they're both base e, you can add their exponents together. And that's what we have here, is we have the same base, but with exponents being added. All right, in each of these numerators, you can take the 9 and throw it back up, and the 2 and throw it back up into the power, right? So this would be e ln of x to the power of 9 times e ln of y to the power of 2. And then both of these simplify based off of those general properties at the very, very beginning. So if you go back here, I'll pull it up on the screen. Whoops. So if you go back to the very beginning, so this is where the section started, talking about the natural logarithms property, we're actually going to use this bottom one, e to the ln of something equals whatever that something was. And in the first case, it's e to the ln of x to the 9th. So that is just x to the 9th. And then we use this same property for this one, e to the ln. In this case, we had a y squared, so it would be equal to y squared. So your solution here is just x to the 9th times y squared. And so the hardest part about these is working with the properties and trying to know when to use what property when and all that fun stuff. So as you're working through the homework, let me know if you have any questions and what I can help you with.